Okay, so from this problem here, we have 10 discs in total. 2 of them are black, and the rest of them, so there's 8 that are white, and I made them green in my diagram here. So we're going to randomly draw a disc and then take it out. So I'm going to go to my bag, I'm going to randomly choose one, and take one of them out. All right, and so G is the probability of drawing a black one. Why did I pick G for green? But a black one. So if I go in, I want success. So I could go in here and choose one black one. So G equals 1. Because I could go in and could be the first one I grab, I could get that. And so the probability of the first one being that one, I is going to be 2 out of 10, which I know is equal to 1/5. Okay, so there's the first one. If G equals 2, well, what that means, the probability that G was equal to 2 means the first one had been green, which would have been 8 out of 10, and the second one would have had to have been the black one, which is going to be then, it's going to be 2 out of 9 that are left. And when I simplify that, I know that's a 1 and that's a 5, and so I got 8 out of 45. And so that's the probability of it being on the second pull. If I come along and I have the third pull, well, the probability that it's going to be on the third grab, well, the first one has to be a fail, which is 8 out of 10. The second one also has to be a fail. It has to be a green one. So there I have 7 green ones left out of 9. And then the third one has to be a success. There's 2 out of 8 that are remaining. And so there's 8 cancel. The 2 here and here makes it a 5. And so I have 7 over 45. If I go to 4, it's the same scenario. It's 8 out of 10, 7 out of 9, and then 6 out of 8. There's a pattern developing here, times 2 out of 7. 7's cancel, 8 cancel, 9 becomes 3, and that becomes a 2. The 2 here is a 5, and I end up with 2 over 15, which equals 2 over 15. If I multiply this by 3 over 3, I get 6 over 45. 6 over 45. If I multiply this by 9 over 9, I end up with 9 out of 45. And I only do this so that I can start to see what the pattern is. And so I'm going to continue going down. And so the very last one has to be the 9th one. I could have all of these being whatever, and the 9th one, then it's going to be, well, 5 is going to be 5 out of 45, and 6 is 4 out of 45, and the 7 will be 3 out of 45, and the 8 will be 2 out of 45, and then the 9, which is the last one, is going to be 1 out of 45 chances. And so that is the probability distribution for if I do not replace, and I want to find all of the, I want to know the probability of finding, pulling out a black one. Finding the expected value, well, then I go expected value, I go of G, I go 1 times 9 over 45 plus 2 times 8 out of 45 plus on and on and on, all the way up to 9 times 1 out of 45. And I'll let you do that computation. Okay, so that was A part. B part now says instead each time it's replaced before I draw another. So let me change colors here. So now, what's my probability of G being G? Probability. So I could again do it on the first grab, and so that probability is going to be, it is still going to be 9 out of 45. If I do it on the second grab, that means the first one had to have been a green one or a white disc, which is going to be 8 out of 10, and the next one would have had to have been 2 out of 9. And so now if I'm going to get, here I get 8 out of 45. For 3, well, each time I goofed. Let me try that again. Let me try 2 again. So for 2, I know the first try is going to be a green, and the next try is going to be a 2 out of 10. So I have 16, so this is 5, a 1, this is 5 and a 4, so I get 4 out of 25. The next one, if it's going to be 3, well, the first one has to be a fail, the next one has to be a fail, and the third one has to be a success of getting the black one. So now it's 8 out of 10 times squared times 2 out of 10. So this is 4/5 squared times 1/5. So 4/5 squared times 1/5. If it's the 4th time out, well, I think you can start to see the pattern is going to end up being 4/5 cubed times 1/5. And this is can go on forever and ever and ever. And so now there's my probability distribution. It's going to follow this particular infinite geometric sequence forever and ever and ever. And so now if I want to come along and find the expected value of G, well, this here is 1/5. This is 4/5 times 1/5. So I'm going to go 1 times 1/5 plus 2 times 4/5 times 1/5 plus 3 times 4/5 squared times 1/5, and so on. I'm going to do that infinitely. And this sum apparently adds up to 5. The last part asks us to make the probability show that each of the domains add up to 1. Well, this here is an arithmetic sequence. I'm going to add up the sum of 9 terms. So it's 9 over 2, n over 2, u1, which is 1 over 45, or 9 over 45 plus 1 over 45. And when we do that, I get 10 over 45 times 9 halves. That becomes a 5, and I can see that it's 45 out of 45, which is 1. Similarly, on the bottom one, when I look at these probabilities here, 1/5 times 4/5 times 1/5 times this one. This here is the sum of an infinite geometric series. So the first term is 1/5. The bottom is 1 minus 4/5, which is 1/5 over 1/5, which again is equal to 1. I hope that helps.